your notebook. Your notebook's on page 31. We're going to finish our discussion about 2.1 conditional statements. Thanks for being so quick about it. Thanks for stacking your warm-ups. I'll come get them in a second. Okay, this very first part, it's all about postulates. Remember when we had our word wall day and you guys were coming to the word wall, putting words up there, but you had to back yourself up with a definition? Postulate was a rough one. Does anybody remember what postulate stands for? Colton, what does it stand for?
It's the opposite of a conjecture.
Yeah, it's like a conjecture, not necessarily the opposite of a conjecture. It uses a conjecture. Does anybody want to add to that definition? So with the postulate, Christian, do you remember? I like that. Christian said it's something that's unproven, but we just trust that it's right. Yeah. Unproven statement. So here we go. On that page 31, there's just a fill in the blank. And I know that you don't really listen when we fill in the blank. So let's go back and we'll talk about it. Okay, so again, take the time to fill in the blanks, and then let's go back and make sure we understand these postulates. Okay, I'm going to shrink the board. Room for pictures. You guys, yeah? Okay, so now we've got a picture of the first one. It's like a conditional statement because you start just with the first part. So the very first part is saying through any 2 points. So that's what we have to do first. Right now, on the side of your notes, draw 2 points. That's it. So start with what they give you first, draw 2 points. So check, here's my point A. Check, here's my point B. And then it's saying, then there exists exactly one line. Is that true? Can we make more than one line through those 2 points? Even though Caitlin definitely has different points than me, can she only make one line through her points? What do you think? Any 2 points, is there only one line available? Absolutely. So that's the postulate. So we're accepting that as true. So start with what they give you and then finish it. Check. Okay, so the next one says a line contains at least 2 points. So that's just backwards from the first one. Do you agree with me? So the focus is, if you draw a picture of this one, you start with a line. So this one, start with a line. Well, on that line, it has to have at least 2 points. In order to be a line, it has to have at least 2 points. But a line, do you agree with me? It has an infinite amount of points. So it goes on forever, right? But it has to have at least 2. So remember, that one focuses on the line first. The other one focuses on the 2 points first. Okay, moving on. Number 7, if 2 lines intersect, stop. Stop right there and draw 2 lines that intersect. Always go with what they give you first. So there's a line. With my arrows, there's a line. Okay, then it says, then their intersection is exactly 1 point. Thumbs up, do you agree with that? It's always going to cross in a point, right? Okay, what's postulate 8? So postulate 8 says, through any 3 non-collinear points, so stop. Draw 3 points that are not in a line, non-collinear. How about E, F up here, G down here? Okay, then it says there exists exactly 1 plane. Oh, the plane's kind of rough. I always think of plane as a piece of paper. Can a piece of paper cover all of them? Or a box? Like, can I make a side of a box catch all of those? Sure. There we go. They all fit on 1 plane. And then isn't 9 just backwards? It is. So 9 says start with the plane and then put 3 points on there. So it's the same picture, but the focus is different from the starting. Okay, number 10, if 2 points lie in a plane, then the line containing them lies in the plane. I think that makes sense. So I'm going to go back to this picture and just add 2 points inside. So maybe we've got point H and point J. 2 points lie in a plane, check. Then the line containing them lies in the plane. Check. Thumbs up. Does that one make sense to you? They're just doing okay. Okay, the last one, I'm going to use the magic of the board to show you the last one. Let me highlight everything real quick. I think the easiest way to do a box, because I'll talk my way through it if you haven't seen this yet. So postulate number 11, if 2 planes intersect, then their intersection is a line. Okay, let's do a cube. So you draw a square in the front, square up and to the right, and then you connect top to top, top to top, bottom to bottom, bottom to bottom, and you've got yourself a cube. Pretty easy, right? Okay, planes. We're using the cube because that's the easiest way to describe a plane. So postulate of 11 is saying if two of those planes intersect, I'm just going to highlight it with the colors. So let's pretend the front of this box is the first plane we're talking about. If this plane intersects with, let's do the side of the box, this part, so those two are hitting each other, look where they're meeting. They're meeting right here. Do you see that? There you go. That's why when two planes intersect, it forms a line. Can you see that now? Thumbs up. Did that visual help you? Planes are a little bit rough, yeah? Oh wait, feel free to put your own visual on there. What page are we on? We're on page 31, right? Because when it comes to your homework, you're going to have questions that describe a picture, and you have to say what postulate it's describing. Remember how I said always stop at the beginning, and that's your focus, and then go from there? That's how you can do your homework, okay? It'll say, and you can just put postulate 11 and postulate 10. All right, last, practicing postulates and counter examples. So what you're going to do as a table, you're going to go through letter A, and you're going to decide true or false. If you think it's true, you just put true, and you get to go to the next one. So letter B, you decide true or false. Then you go to the next one. Letter C, you decide true or false. If it's true, you move on. If it's false, back it up with a picture showing it's false. If it's true, move on. False, back it up with a picture and move on. Are you ready to work as a table? Heads up, I'm going to call on any table I want. Ready, set. I'll give you time to work first. Go. All right, now that I've given you time, are you ready? Let's call on, let's go Tyler's table. What did you guys get for letter A? True. Guys, clap once if you agree that that's true. Okay, you know what? I just realized the pictures are in your notebooks. Did you see it gives it away? Check. All right, letter B. Let's call on Callie's group. Callie's group, what'd you put for letter B?
True.
True. Clap once if you agree with that. Okay. All right, letter C. Let's call on Sarah's group. Sarah, what did you guys put for letter C? False, absolutely. Man, that wasn't as awesome as I thought it'd be because you have. These are the pictures, right? So A, check. Definitely a point can land on one and one line. Guys, is 3 the only possibility? Could we go way higher than that? Yeah. Absolutely. We can keep going. And then letter B, 3 lines can intersect at no more than 3 distinct points. There's no way to make it more than that, right? If you only have 3 lines. Okay, last one. I called on Sarah's group specifically because they were talking about parallel lines. It's fantastic. So you've got that picture in your book, right? Parallel lines, they will never cross each other. Okay, now what you're going to do is finish yesterday's worksheet. You should already have 1, 2, 3, 4, 5, 11, 12, 13. Now you do the rest. Honestly, keep your notebooks open to page 31 because you'll need those postulates.